Hey everyone, Nick Dearbirdis here teaching you financial modeling. And today we're going to be talking about implementing a dynamic salary retirement model in Excel as part of our lecture series on the depth of a financial model focusing on Excel. So we have been talking about this retirement model, and we already implemented the simple retirement model with a static salary, and now we're going to go to implement this one where the salary increases every certain number of years with a promotion and also increases annually with a cost of living raise. So as we go to build our model, now this model is going to be larger than the one we looked at before. And really we can break it down into multiple sub-models or sub-problems that we can tackle individually. So the first sub-problem here is determining the salary in any given year as we go through time throughout this person's career. And then the next is determining the wealth of this individual as they take that salary and save a certain portion of it and invest that and earn an investment return on that. And then finally, the retirement side of the model, which looks at the wealth to determine when this person can actually retire. So we've got these three parts of the model, and they're going to become three separate worksheets here in the model. But when you have a model which has these multiple parts, it's also good to have an overview page which gives you, the main inputs and outputs from the model overall. So let's go ahead and build out that inputs and outputs page. So you could call it overview, or you could call it inputs and outputs, or something along those lines, which just says, this is the main page, this is the starting point for the model. If you want to change things and have it flow through the model, you change the inputs here, and you'll see the outputs here as well. So first I'm going to create the inputs section. And for the purposes of going through this, I'm not going to be really adding formatting for the most part to this. When you look at the completed example on the site, you will see that it has all the formatting in place. So definitely you should be adding formatting to your models before you present them to anybody. But just in the interest of time, we're going to focus here on, actually building out the logic and the layout of the model. And I'll leave it as an exercise for you to add the formatting. So in the inputs here, it's good to be as clear as possible about, what each input is about. And here, we've got the three different parts of the model. And so we can kind of separate the inputs into those three parts as well. So we have the salary inputs for whatever inputs are going to go into ultimately determining that salary year over year. So we have the starting salary, and we said, we can say that starts at 60,000. And then, we've been saying that there's going to be, every certain number of years, there's going to be a promotion for this individual. They're going to get a certain raise. So let's just start it out saying every 5 years, they're going to get a promotion. And, that'll be an input to the model, so we can adjust how quickly those promotions are going to come, which would definitely make sense, for people on different career paths, plugging in numbers which are appropriate to their particular career, how often they're going to get promoted, and how big of a raise they're going to get upon promotions. So then we have the cost of living raise, is how much they're just getting annually, year over year, every year as a raise to compensate for inflation. And then the promotion raise is going to be, whenever one of those promotions occurs every 5 years or whatever the values of the inputs, then they're going to get that much of a raise in that year on top of the cost of living raise. So those are the salary inputs, and then we're going to have some inputs going into the wealth portion of the model. So that's going to be the savings rate. which will tell us, out of that salary they're earning, how much they actually invest and not just use on daily expenses. And also the interest rate, how much they're going to earn on the investment. And then we have the desired retirement inputs, so that's just the desired cash of currently having that at $1.5 million. So certainly you would want to add all the number formatting and bold the header areas and put this in a box and everything to kind of separate it, but we'll leave it there for now. You can take a look at the completed example for the formatting. And then for our main outputs, we're just going to have one output here. It's going to be the years until retirement. So we'll just put that placeholder there, and then we're going to bring our main result to here at the end. So that's the overview sheet, and this should really be the one spot that your hard coding values is for your inputs here. The rest, everything is going to be cell references. So next we can go to build out the salary portion of the model. So I'm going to create a new worksheet here in the model, salary worksheet, and in here we're going to figure out what is the salary in each year going through time. And I mentioned before how as we have our more complex, larger Excel model and we're breaking it down into basically submodels of one per worksheet, we also want to maintain that same input and output separation in the individual submodels or worksheets as well. So I'm also going to create an input section on this worksheet, which will just be bringing over those inputs from the main tab over here. And because we already separated everything out really nicely over here, it's easy just to reference over to the other tab, and then we can just drag it to be able to get all those values over here. So now we have those same inputs coming to this tab as well. And then we can go on to create a separate area which has the calculations for our salary. And there's two main reasons to bring those same inputs over here, even though they were already defined over here. So one is that then each each worksheet here, each submodel is self-isolated. Everything you need for that individual part of the problem is right here on this worksheet. And then the other part is, as you do calculations with these things, you reference them here, and you can see we just have, B2 as the reference there. Whereas you look at these references, it's inputs and outputs B3, inputs and outputs B4, etc. And so if you have these in all of your different calculations going through, it actually becomes very difficult to read your calculations as, the references become so long, it becomes difficult to tell what's going on. So you can keep the formulas nice and short if you're referencing things only on the same tab in the calculations, and these are just directly linking to those inputs from the main sheet. So we want to ultimately determine, year over year, what is the salary going to be. So we can start with year one, and in Excel, if you type out a couple numbers in a row, from there you can drag it. It's going to be able to figure out the pattern. So we do that, and then we're able to, let's go a little bit further on that. Let's say go out to 40 years. So then we have our full, 1 through 40 different years to build out the different salaries. And I think it's, always a good idea in Excel models to try and split out the calculations as much as possible. You don't want to have really long cell formulas. That's just going to become very difficult to understand what you're doing. If you ever do have a long formula, you want to make sure that you add a comment that explains what that formula is doing. But it's even better if you can just make each calculation very clear and straightforward, and larger calculations are split across multiple cells, so that it's much more clear without even having to add that comment. So I'm going to tackle figuring out the salary in a few steps here. First is I'm going to figure out, is this a year where we're getting a promotion? And then I'm going to figure out how many promotions have we had up until this year, and then figure out the cost of living raises, factor in the promotion raises to bring it all together to the salary. So first, let's think about, is it a promotion year? And so for this, I mentioned in the prior video that this is where the modulo becomes really useful, because if we do equals mod of the year and then the promotions every number of years and make that a fixed reference, then as you drag this down and you look at it, you'll see we go 1, 2, 3, 4, 0, 1, 2, 3, 4, 0. Every year that it is actually a promotion here, because it's every 5 years, so year 5, year 10, year 15, every one of those is coming up as a 0. So we know that it's a promotion year if the value we're getting here is 0. And we can look at changing to a different number of promotion years, let's say 3. Now we can see that it's every 3 years we're getting a 0. So this 0 always tells us that we are in the promotion year. So I'll change that back. And then we can see that we just need to build one additional step on this to be able to tell, is this a promotion year? So that additional step is we can add an if function around that. So remember, if we think about a logical condition, and then if that logical condition is true, we're going to get one value. If it's false, we're going to get the other value. So the condition that we can make here is this calculation that we did and we've just been looking at, is that value equal to 0? Because we know if it's equal to 0, then that is the promotion year, right? And so if it's equal to 0, aka if this is a promotion year, then we want to put a 1, because 1 can represent true easily, and we can use 0 to represent false. So then with that, do that, and we can double click to complete that all the way down, and now you'll see it's giving us a 1 in those promotion years, and it's giving us a 0 otherwise. And if we change this to a different number every 2 years, now we have every 2 years we're getting that it's a promotion year. So now we know which years we're getting the promotions, but if we go back to the formula that we're trying to implement here, we don't need to know, as far as this formula is concerned, whether it's a promotion year. What we need to know is how many promotion years have occurred up until this point in time. So that's what this P in this formula is representing. So then the next step is then to figure out the number of promotions that have occurred up until that point. And so we can do a very common pattern in Excel here to determine this, and that's what's called a cumulative sum. So that's just summing up from wherever you're starting up until the end of the range as you drag it down. And so the way you do that is with the regular sum function, but here we're going to sum from the first number to the first number. And that sounds like, wait, why would we sum from something to itself? What was the point of doing that? It's because we're going to make the beginning of that sum range a fixed reference while leaving the other one as a relative reference. And what that allows that to do is when we complete this down, we can see that as soon as we get a promotion, it goes up. Each time we hit a promotion, it goes up, and then it keeps adding to that. And that's because if we look at what happened in one of these individual calculations, that the bottom of the sum range keeps moving because it's a relative reference while the top stays fixed. And so it's going to be adding whatever has occurred up into the point. The sum range just keeps increasing as we go year over year, so it's a cumulative sum. So then with that, we know in any given year how many promotions have occurred up until that year. So now that we have figured out the promotions piece, now we can turn our attention to thinking back to this formula. We split it down into three parts: the initial salary times the what we can call here the cost of living factor is this portion, times what we can call the promotion factor. And so now we can go and calculate each of these two pieces as individual factors. And that's part of what I'm talking about in splitting up your calculation in Excel. It's certainly possible to just go and do this all in a single cell, but it's going to be difficult to understand what you're doing. So splitting the calculation up, it becomes a lot more clear, and you can analyze individual parts of the calculation a lot easier and ensure that it's working properly. So we're going to calculate the cost of living factor, and that is simply what you saw in the equation. It's just 1 plus the cost of living raise. I'm going to make that a fixed reference because we want it to always be that particular cell. And then I'm going to take that to the power of the current year. And that one we do want to be relative so it can move down over time. So then we see, from these cost of living raises, basically by 40 years, you're going to be making more than double your initial salary just on the basis of having 2% inflation each year. Then we can go and calculate the promotion factor. So for the promotion factor, it's going to be a similar format. 1 plus the promotion raise this time instead of the cost of living raise. But now we're going to take it to the power of the number of promotions that have occurred up until that point. And that one we do want to move down with us. So then we can see, in the first 4 years where there hasn't been a promotion yet, it's not going to ultimately change the salary. It multiplies it by 1. But as soon as we get our first promotion, a 15% raise, now it's multiplying it by 1.15, and so that's a 15% raise. And we see every 5 years that factor goes up, representing that we got a raise. And so we can see, if every 5 years you get a 15% promotion, then you're going to be making 3 times as much as when you started after 40 years. Just based on those promotions alone. And so then we can put those two things together. Remember that in the formula they were just multiplied together, and so I added that here. Just multiply the two together, both relative, to get the total factor. So then we can see, with the inflation as well as the promotions by 40 years, we would be making close to 7 times what the initial salary was. So then the last step here is just to actually calculate that salary. And for that, then it's just putting everything together. So, we already put each of these two factors, and we just multiplied them together into a single number as the total factor. And so now we just have to multiply that by the initial salary. So we're just going to take the initial salary and make that a fixed reference. It's the same for each one of these, and multiply it by the total factor as a relative reference, which is going to come down with us. So we do that, and so we see, starting at a $60,000 salary, 40 years later, you would then be making $400,000 based off of these numbers. So that's the salary portion of the model, and then we can move on to building out the wealth portion of the model next. So in the wealth portion of the model, we're now going to be using this salary that we calculated year over year to ultimately figure out the wealth in any given year. So, again, with all these sub models, we're going to have our own individual inputs section. And as part of this, we're actually going to be bringing over this entire column of the salary year over year. And so, that's not going to fit well into this inputs box. It'd be nice just to have it as part of our table of calculations. And so what I like to do in those cases is I just put a note that salaries are computed on the salary tab, then referenced here. And, that's just saying, we're going to have the salaries going through here. It just makes it very clear to the consumer of the model that those were calculated over here, and it is a lot clearer how everything fits together. So then the other things that we'll want to bring over for this are the starting salary. We can get that from here, as well as then we can reference the wealth-specific inputs, the savings rate, and the interest rate. So then we have our input section, and we can go on to do the wealth calculations. So we're gonna again have calculations year over year, so you can either redo the same thing with the time, or I'm just gonna go ahead and reference this column here to get each of those years. And then we also need to bring over the salary from the other tab. So now I'm going to reference that over to the salary over here. So now we have the salary year over year on this tab as well, and it's very clear that that was calculated on the other worksheet and brought over to here. So then there's kind of two steps here in calculating the wealth. So the first is seeing, how much did this person save in this particular year, and then the other is applying the investment return to the existing portfolio as well as the new savings, or to the existing portfolio, and then adding the new savings to come up with the wealth in that given year. Next we can calculate the amount saved. And so the amount saved is simply going to be the salary earned in that year times the savings rate, and we want it to be fixed to the savings rate, as we always want to use the same savings rate. So we complete that, and then we have the amount saved year over year, and then we can go to calculate the wealth. So the wealth in the first year here would be just, we don't have anything in the portfolio yet, so it's just the amount that they saved, and then it's going to be invested over the following year. So then going forward after that, it's always going to be taking the prior wealth, and it's going to be multiplying that by 1 plus the interest rate, and we want that to be fixed. Always use the same interest rate. And then we're going to also add in the amount that was saved in that year, because that was just earned. It hasn't been invested yet, so that part doesn't earn the investment return until it's included in the following year. So then with that, that is the formula we need for the rest of this. And that will get us to ultimately this person earning $3.9 million in their portfolio for retirement by 40 years from now with these basic inputs. So then the last portion of this is then the retirement portion of the model. So the retirement portion of the model is about figuring out when this person can retire based off of the wealth they've accumulated and how much cash they need in retirement. So we can, again, make our input section as always, and here we're going to need the wealth year over year to determine this. So I'm going to, again, put a note like I did on the other tab that, we can't fit all the wealths up in this corner. And so we're just going to say that wealths are computed on the wealth tab, then referenced here. And then the only other input that we're going to need is the desired cash. So we'll bring that over as well. And then we can then make the area for the calculations, retirement calculations. So here we can go ahead and bring over the time, like we did for the wealth tab, reference it from the other tab, or you could just do the same completion thing that we did to create the time column in the first place, here going up to 40 years. So then we need to we need to bring over the wealths next. So there again, we're just going to reference over to the other tab and bring that over. And then we want to figure out in any given year, is this person able to retire? And the condition to be able to retire is that we have saved enough money, right? That we have a wealth greater than the desired cash. So again, we can represent that with an if statement here. So if the wealth in that year is greater than the desired cash, the fixed desired cash that we use every year, then 1 is going to represent yes, we can retire, and 0 cannot retire. So then we complete that, and we should see right after we cross over that 1.5 million threshold, indeed it says we can then retire. So this is saying after 28 years, then this person can retire. Then there's just, basically we have our main result here, but we want to be able to get, a single number coming over onto the inputs and outputs tab. And so then this last part, you may have noticed that I left this first column intentionally blank here, and that's because I was planning on doing a VLOOKUP on this table to determine the row in which they first are able to retire. And so for that, I can, the issue with, using VLOOKUP with, this kind of column is it goes from 0 and then it goes to 1. And so if you, want to look up the 1, it should be this one, but, it could be more direct to figure out the number of years that they've been retired, which would just be a cumulative sum. So again, that same pattern of, from the first cell to itself, but the first part of that is going to be fixed. And then we can complete that down. And then we can see that starts to count up after this person is able to retire. And so then if we try to look up the row that has a 1, we can be certain that it's going to be this row, 28 years, which is the first year that they're able to retire. So then the last part is then just coming over to the main inputs and outputs tab, and we're going to actually write the VLOOKUP function. And so here we want to look up the value 1, right? We were talking about the number of years retired. As soon as that hits 1, they have retired in that year. And then we want to look at the retirement table. So I'm going to go and reference this table here, and we really only need the first 2 columns because we're trying to look up the year value here. We don't care about the other values for this lookup. And then we want to get the second column's value, right? The column which has the year in it. So we do that, and then we can see that we indeed get 28 as our result. So that way, we have everything on one tab. That allows us to easily say, well, what if I could, get a better job starting out and start out at $70,000? Oh, well, that changes the years to retirement now to 26 years. And then you can look at the other tabs. You see everything, the salary came through. It changed all the salaries over here, and that came through to changing the wealth over here. And we can see the retirement. All the calculations have changed here. And so everything flows through the entire model to ultimately get us to our main answer here. And structuring our model in this way makes it really easy for someone who is not familiar with all the inner workings of this model to just come in and play around with it and think about different values for all of these inputs, whatever makes sense for their situation, and they can just see the result very easily without having to get into the details of how this model is implemented. But if they do need to dig into that, say this is someone coming and they want to build out a better wealth assumption, they want to build in recessionary and expansionary periods and have the investment returns respond to that, then they can focus just on this wealth tab, and they don't have to worry about how the salaries are being determined and how the retirement is being determined. They can just work on the wealth portion, and that makes it a lot easier because you can just focus on this one submodel rather than having to think about how everything fits together. By having very clear inputs and outputs from each submodel, it is a lot easier to maintain the model going forward. So that wraps up the content for our section on the depth of a financial model and implementing that in Excel. And we're just going to come back to discuss the lab exercise to conclude this section of the material. So thanks for listening, and see you next time.